Good evening, students. I hope you all are well as your family members. Today we will start our chapter solution, that is second unit in the 12th class. Solution is of two types. First is homogeneous solution and second one is heterogeneous solution. As the word indicate, homo means uniform and genus means composition. In same manner, hetero means non-uniform and genus means composition. It means homogeneous solutions are those having the uniform composition, but heterogeneous solutions are those having non-uniform compositions. For example, we take a container and in this container we dissolve sugar inside the water. We observe that sugar is completely dissolved inside the water. There is no any sugar settled down. It means it is a kind of true solution. But in another container we dissolve or mixes sand inside the water. Then after some time sand settled down as we stop the stirring. It means it is a heterogeneous solution. In this chapter solution, we only discuss about the true solutions. Now, one of the important topic in this unit is the vapor pressure. As the terms indicate, vapor pressure, simply the pressure exerted by vapors on the surface of liquid when present in equilibrium in a closed vessel conditions. Now, understood this by taking an example. We take a container that filled with a liquid and we know that every liquid have the property of vaporization, that easily converted into the vapors after getting the heat. We heat that liquid, then what happened? There are the molecules that present on the surface and known as the surface molecule, and the molecules which are present in the center are known as the bulk molecule. Here we easily understood that the bulk molecule is uniformly surrounded by all side by other liquid particles, but in the surface molecules there is only the forces of attractions on the inner side. There is no any forces of attraction on the outer side. It means they have less forces of attraction. And when we heat the liquid, what happens? there is increase in the temperature. With increase in the temperature, there is increase in the kinetic energy of the particle. As a result, particles are easily escape from liquid to vapor phase, and that process of conversion of liquid into vapor is known as vaporization. Now, in this open vessel condition, we are not able to observe the phenomena of vapor pressure because according to definition मैंने आपको condition क्या दी है, closed vessel condition. If we closed that vessel, then the vapors are formed here. Initially, the vapors formed are very less in amount, but with the passage of time, the amount of vapors increases. So they come closer to each other. As a result, there is increase in the forces of attraction. As a result, these vapors get converted back into liquid, and that process of conversion of vapors into liquid is known as condensation. It means in that closed vessel condition there is an equilibrium between vaporization and condensation. And when the vapors are present in equilibrium with liquid, then they exert the pressure, and that pressure is said to be the vapor pressure. Now topic is clear. Now the next topic is factor affecting the vapor pressure. Our next topic is factors affecting vapor pressure. The first factor is nature of liquid. Here, nature means forces of attractions. It means the liquid having the more forces of attraction, having the less vapor pressure, because more forces of attractions, less vapor formation, and less vapor pressure, or vice versa. For example, ether has more vapor pressure than water because in ether there are weaker forces of attraction as compared to water. That easily understood with the help of the type of the forces of attraction. In water, there is presence of the hydrogen bonding like this and so on. But in ether, the formula is ROR. Oxygen is more electronegative than R group. R is any one of the alkyl group. So here is partial negative and these have the partial positive, where the separation of positive and negative poles are known as the dipole. So there is simply the attractions are the dipole-dipole attractions. But in water there is presence of hydrogen bonding, and hydrogen bonding is slightly more stronger as compared to the dipole-dipole attraction. So in water the magnitude of forces of attraction is more, so the vapor formation tendency is less and there is less vapor pressure. And the second factor is temperature. As we all know, kinetic energy is directly proportional to temperature. So with increasing temperature, kinetic energy of liquid particles increases. That increase the escaping tendency of liquid to form vapors. So more vapor formation and more vapor pressure, or vice versa. I hope you easily understood that topic. Now, next topic is Raoult's law, or vapor pressure of liquid solution, or Raoult's law for volatile components.